Um, Again, thank you for attending SEM Link's Virtual Teen Science Cafe. My name is Askari Bumphis, and I am this organization's program assistant. It's my privilege to introduce our guest speaker for today, Dr. Ethell Vereen, a professor of biology at Morehouse College in their Science, Technology, Engineering, and Mathematics division. Today, he and his assistant, Aaron Walker, will be demonstrating on topics related to environmental microbiology.
Thank you for that wonderful introduction. And I am going to share screen. We did put together just a brief presentation with everyone. So we do want this to be interactive as well. So if you could, please monitor the chat for us. If you have questions during the presentation at any time, please feel free to ask those questions in the chat or simply raise hand or unmute and engage with us. So let's go ahead and let's get started. Yay. All right. So the title of this talk that we have for the Teen Science Cafe is Career Pathway Conversation on Environmental Health Research. Specifically, we're going to talk about water for life and livelihood, and also we'll talk about some microbes as well. So we do want to begin with a brief acknowledgement statement. So this acknowledgement statement is a land and people's acknowledgement statement. And hope you'll take a moment to connect to where you are in their space, focus your mind, body, and spirit. And reading this to your hearing, we acknowledge that indigenous people and nations have stewarded the lands of the United States of America through generations before anyone settled here from elsewhere. At Morehouse College, where we know present and future can only exist upon the bedrock of the past, we pay respect to the Muskogee and Cherokee people who are the original peoples in the Atlanta metro area where our campus sits. We acknowledge the enslaved people who were brought to this land against their will and on whom this country benefited and continue to benefit to flourish economically and culturally. It is upon the sacrifices of generations of our enslaved ancestors, as well as ancestral communities that experienced forced separations due to slavery, that we are given the opportunity to thrive. Here in Atlanta, one of the birthplaces of the civil rights and environmental justice movements, we offer gratitude for the courage and sacrifice of those whose names we know well, and some we have yet to know, who have paved the way for us to be here today. We acknowledge the rich history surrounding us and continue to aspire and contribute to a just, flourishing, and healed world. We also want to offer just this brief disclaimer in that any opinions, findings, and conclusions or recommendations expressed in this presentation are those of the author and do not necessarily reflect the views of any associated or affiliated organizations. For an outline of this discussion and what we'll be chatting about today, we're just going to start with just getting to know each other. We'll introduce ourselves, and then that will be followed by our journey to becoming, or my journey to becoming a STEM professional. We'll focus on environmental science specifically. And then we'll talk more about our actual research interests. What are some of the things that we're doing here at Morehouse? And then we'll have a scholarly activity where we do invite you to engage with us in this activity. And then finally, we'll have some time for questions and discussion. So for this first part, sort of introducing who we are, so I am, again, Dr. Vereen, Ethell Vereen. Dr. V is fine. I'm an assistant professor of biology at Morehouse College, and the scholar or bioscribe who's joining me today is Mr. Aaron Walker, who's an undergraduate research assistant here at Morehouse College. But this is not all of who we are, right? So for me, I also identify as a first-generation scholar. I attended a HBCU, a historically Black college and university. For most of my formative years were spent in South Carolina. My family did move around some, but most of the time was spent in South Carolina. That's where I ended up graduating from. So there's a connection to South Carolina that I have. And then also I find myself presently here in Georgia. And I share here that I am Black history and Black future because, yes, I do identify ancestrally as a Black American here in the US, knowing that my ancestors did come to this country as enslaved persons, but I do have an affinity for America. When we do travel abroad, people see me as an American and not just a Black person, if you will. So there's this connection with the diaspora. I'll talk more about the institutions where I've conducted my training at South Carolina State, the University of Georgia, and Emory a little later in this talk. But I also would like to share that, I am a married person. My partner or my spouse is Patricia. We do have two young boys, Aiden and Anderson. So shout out to them. And we are Team Vereen. So you see here our actual family crest. for us. And so we've included that there. But then I also enjoy music, and not just science, but I also enjoy music as well. And so I say that I am a scholar, I'm a science teacher, I'm also a learner. And then this upper image is the VRI, the Vereen Research Institute, which is the lab area that I do facilitate. And so with that, I'll allow Aaron to share in his own way with his introduction.
Hey everyone, my name is Aaron Walker. I am a senior at Morehouse College. I also am the president of the Morehouse Biology Club. Professionally, I'm a certified pediatric critical care assistant as well as a pharmacy tech. So a little about me. I love to travel. The picture at the bottom left corner shows me in the pharmacy running prescriptions. Next to it is a cougar because I have an associate's degree in applied health sciences. In the middle is a black guy in scrubs. I feel like that picture is so important because we don't see a lot of us in the hospital. Also from Alabama, I'm a bioscribe for Dr. Vereen. At the bottom, I love research. I do a lot of research in the rivers, the Chattahoochee River outside of Atlanta and other creeks. And I also am a third generation Haitian American. And I'm going to give it back to Dr. Vereen now.
Thank you, Aaron. So that's a bit about us and our background, right? But conceptually, we know that life began here on this planet billions of years ago, right? On the Earth. But now it's a fact that our world is facing these massive, massive challenges. And so when we think about that, we think about, well, what are some of the challenges that you feel are facing our planet today, right? So we see the Earth here. So if you just post in the chat some of the challenges that you think are facing the planet, that would be awesome. So we'll give a quick minute for folks to place that in the chat. All right, thanks for sharing and sharing out, right? So some of the things that we shared when we were putting this talk together, some of the things that we feel that are happening are you know, uh, global pandemics, poor governance, food waste, overpopulation. There's plastic pollution, there's air pollution, there's biodiversity loss. So you can see there are a number of these challenges that our planet is actually facing. So hopefully you'll add to this as well and think about, some of the things that you feel are impacting our planet. Hey, thank you, Aaron. See, global warming, lack of water, and soil erosion. Excellent, excellent. So with all of these things that are happening on our planet, both our actions and our inactions today will have consequences on the future of our planet, right? So the question then becomes, well, what can we do about it? What can I do about it, right? And so the first thing we're gonna do is really think about the person that we see in the mirror and think about, well, what can I do? And there are all these things that we can do to protect our planet. And that, of course, starts with us. We can bike more, drive less, we can reduce, reuse, recycle. We can choose sustainable food, especially seafood. We can buy less plastic and bring a reusable shopping bag. We can use LED bulbs. These energy efficient light bulbs reduce greenhouse gas emissions. And also remember to flip the light switch off when we leave a room, right? So there are all these things that we can do. We can also volunteer and we can plant trees. So there are a number of things that we can do. But the other thing that we can do is that we can actually choose to pursue a career in environmental health sciences. Yay, environmental health. So as an environmental health scientist, you will be on the front lines of safeguarding public health and conserving our world. So we should think about this and consider a world in which the air is pure, the water is pure, and the environment is safe for everyone. This is the world that you will actually work to build as an environmental scientist. You'll be able to conduct research, devise solutions, and put policies in place to actually reduce environmental dangers and preserve human health. Of course, the effort may seem to be difficult, but the benefits are, of course, enormous. And every day you'll make a visible impact in people's lives and the health of our world. So, of course, as I shared this sort of transition, you'll get to make a difference. A career in environmental health science will allow you to have this genuine practical effect on people and the planet's health and well-being. And you'll do this every day. This is also an interdisciplinary field, in that there will be persons that you'll work with that might be biologists, they may be chemists, they may be engineers, and they may also have public health backgrounds. And you yourself may have, expertise in some of these areas, or at least a strong affinity, or a strong, you're really good at some of these areas, or a combination of these areas, which will make you a very good environmental scientist. This is also a growing field, and that environmental science and environmental health science especially is rapidly expanding. And there's a growing demand for specialists who can actually address many of the environmental issues that are facing our planet, and many of the environmental issues that are unfortunately going to continue to affect us. There are a number of different career paths that someone can choose to follow to become an environmental health scientist. And we'll talk about a few of these shortly here, but they can range from being an environmental health officer through becoming, an industrial hygienist, an air quality engineer, an environmental toxicologist, an epidemiologist. So there's a lot of different prospects and career paths for a person who wants to become an environmental health scientist. And you're like, yeah, Dr. V, that sounds great. But what a lot of our young people and scholars actually ask and want to know is, well, what does the salary look like for this potential career path? Well, I'll share that the environmental health science salary in the United States is actually very, very good. So I'm showing here, this is a swath of the United States. This is recent data. This was last updated September 1st of 2024. So the national average for an environmental health scientist is about $84,000 a year. And you can see here variations based on different states, and where you might live, different regions. So the darker colored areas, these are going to be persons in those states that are going to make a bit more than some of the lighter colored states, like Florida. Unfortunately, a person living in Florida as an environmental scientist is not making as much as a person that might be living, say, in Washington State. But then also, if we want to look specifically in Atlanta, Georgia, where we find ourselves, the actual Atlanta average is $84,000 per year for an environmental scientist. So this is actually above the national average for a person who's living here in Atlanta, Georgia, which is pretty cool. And so there is a range of these salaries, and sort of on the higher end, you have persons who are in, like molecular biology, so these research scientists, and then on the lower end, you might have some consultants. But they're still making a nice, very nice, decent salary. As I mentioned, this is an interdisciplinary field, but it's also quite global. So I wanted to share with you just some of the salaries across the globe, so you don't have to limit yourself or only think that, hey, I have to live in the US to be an environmental health scientist. No, you could live in anywhere on the planet as an environmental scientist and actually still make a very nice living or comfortable salary for yourself if you're thinking about the funds. But then also you're going to have the thing that's not measurable by this is the impact that you actually make on the environment and on people. So some of the salary ranges in South Africa, about 24,000 a year, and then in Japan it's even higher, where it's 1.3 million yen that a person is making there. And so you can do the calculations for US dollars to see what that would look like. And I will share that because taxes differ across different sectors and locations, it's difficult to accurately calculate the net salary after tax for every career. And what we're showing here are gross salary figures. So these are figures before taxes. And then also using salaryexplorer.com to actually look at the salaries for the US, about everyone, or 100% of persons in the US, are going to make a salary about $236,000 per year as an environmental scientist. That's their average yearly salary. And then the base or entry salary for an environmental health scientist is about $72,000 a year. That's our average introductory salary. So just coming out of college or completing a degree, this is what you can expect to earn as an environmental health scientist. But again, you can earn a living and also save the earth. But again, the most important part about this is the role that you're playing in society. The funds are great, but you're gonna make these vital contributions to protecting the planet as well. So by pursuing a profession in this sector, you'll be able to make this genuine impact in the world. So what does the pathway actually look like to becoming an environmental scientist? So you care about the earth and you want to have this meaningful career. And to get this fulfillment and prepare yourself for an environmental science job, what does that career pathway ultimately look like? Well, as you can see here, there are different pathways that a person can follow to actually become an environmental health scientist to get to this career pathway. Some of these might actually not include high school. You could potentially go directly into a technical field or technical education. To go into a career path, completing high school, you can go into an apprenticeship, certification, associate's degree, or bachelor's degree, and then also ultimately some advanced degrees. And we'll talk a bit more about what that looks like. So I know that we're sharing here with a lot of teens and youth, but this is the great time to start thinking about what are the things that you like, your self-awareness, what are the things that you find joy and fulfillment in, and then how might that lead to different ways for you to actually explore these different career pathways, and then actually think about your career and actually plan it out. So it's not too early to actually start doing that from middle school to 10th and 12th grade as you're then making this transition to actually graduate from high school, and think about what does your life look like beyond high school? What does that post-secondary life look like? So think about the different expectations, exposure, and experiences that you can have even now that are going to prepare you for this particular career pathway. And really, this is for any career. And so I'll share that oftentimes when we're thinking about this transition from high school to college or university, we're thinking about pursuing this actual degree, there are some differences in some universities where they offer degrees in environmental studies and others offer degrees in environmental science. And yet still there might be some institutions where they do not have this specific career field, and you might pursue an actual career in like biology or chemistry or some other STEM field, and then still continue on to become an environmental scientist. So there's a difference in environmental studies versus environmental science. Whereas programs in environmental studies, they usually involve fewer science courses, and this would be found at more of your liberal arts subjects such as law and economics, so persons who are maybe going into policy. And then programs in environmental science, they actually dig deeper into the science part of this, into the STEM part, where these would include programs in physics, biology, and organic chemistry. It might be advanced statistics, engineering, and also technology. But I share here a little note that before you decide on a path, research your dream jobs to see which degree is preferred, whether that be environmental studies or environmental science, because some employers may specifically want an environmental science qualification, and you want to make sure that you have that as you're pursuing this specific type of degree. And so there are these different types of degrees. So like many scholars, the first I'll share is an associate's degree. So this might be the first step towards an actual bachelor's degree, or you could look into becoming a research technician or a laboratory assistant with an associate's degree. But think of this as an associate's degree. It's a 2-year program, which is designed to introduce you to the field, really any field, but specifically here, we're going to focus on environmental science. So these courses often cover biology, chemistry, math, environmental studies. They usually might involve actually fewer science courses, and they may be geared toward more liberal arts subjects for your associate's degree. And this could be, again, an associate's of science in environmental science or an associate's in environmental studies. And many students, again, use their associate's degree as their first step towards the bachelor's degree. And there are a number of online associate's degree programs now that scholars can also complete. But make sure that whether you're completing an online associate's degree or an in-person associate's degree, we're actually going to a campus, that you check that the credits are actually going to be transferable to your actual bachelor's degree. And so now we'll just briefly touch on a bachelor's degree. This is actually a 4-year program that's intended to give you sort of a firm grounding or a setting in environmental science. This can be used as a starter position for different career paths, such as a science teacher, a sustainability consultant, an environmental policy analyst, a lobbyist, or a soil conservationist, or it may be the basis for continuing your work to go on to graduate work or professional school. And to do that, that's where you're going to want to gain more responsibility and freedom in the field for graduate studies. And that could be like a master's program. And we'll talk about those shortly here. But for different bachelor's programs, we have a bachelor's of environmental science, a bachelor's of environmental health engineering, a bachelor's of environmental studies, or a bachelor's of science in environmental toxicology, just as some of the more common bachelor's degrees that you'll see in environmental studies or environmental science. But again, you could also just have a bachelor's of biology or chemistry and still then pursue a master's degree or a doctorate degree. So with the master's degree, you would you could also consider your master's degree in a specific subject, and not just a master's degree in environmental science. But a master's degree, this is sort of a more challenging 2 to 3 year program. So you have your 4 years of your bachelor's degree, 4 to 5 years typically now, and then your 2 to 3 years for your master's program. This is going to deepen your understanding of environmental science. Again, you can have a more specified study area where you might focus in on environmental pollution or environmental toxicology or ocean studies. But whatever topic you choose, your master's degree will actually open the door to higher pay, management positions, and a host of different career options. Some of the master's degrees that we have listed here, more typical might be, again, is Master's of Environmental Science, a Master's in Environmental Studies, a Master's in Environmental Health Engineering, a Master's in Environmental Toxicology, as well as a Master's of Public Health, or your MPH. Your MPH degree. And then following the master's degree, there are scholars who go on and obtain a doctoral degree. The master's degree is not actually required for a doctoral degree or a PhD. You could actually leave college, graduate your bachelor's degree, and then go directly into a doctoral program, a PhD program. And I actually suggest that for a lot of scholars who know that that's the pathway that they want to go on, because there are actually some programs where if you go directly into the PhD program and you get into that doctoral program and you decide that, well, maybe this is not the actual program that I wanted to go in, there are a lot of universities and institutions where they have built in sort of an off-ramp where you can actually complete a master's degree program at that point. But with some of the programs, if you go in and you obtain a master's degree first, that might be 2 to 3 years that you're adding on to your actual program. That's going to have the additional 4 to 7 years for the doctoral degree. So you can see where those number of years post high school are starting to add up. So that's why, again, for me, I suggest to a lot of scholars, if you know that you're thinking about obtaining your doctoral degree and becoming a doctor, then upon leaving college, you might want to go directly into a PhD program, or doctoral degree program. So these PhDs can be a PhD in environmental science, or a PhD in environmental health, a PhD in environmental health engineering, a PhD in environmental studies, or a PhD in environmental toxicology. Many holders of PhDs in environmental science do teach at universities, or they work in research lab. Others go the route of becoming an independent consultant, or potentially even an entrepreneur. A PhD is generally just showing someone that you know how to think, that you are a critical thinker. And there are also these certifications. So this might be another route for those scholars who may not want to go to college, or they may want to go to college, but then they don't want to go on to graduate or professional school. You can actually earn an academic certificate. This is not the same as gaining as gaining a graduate degree, or even gaining professional certification, such as becoming a certified environmental scientist. Those, or like a CES, certification bodies have very specific academic and work requirements for those specific degree requirements. So these type of certifications are actually aimed at persons who might have a bachelor's degree. So in some cases, you might actually have to take an exam for these certifications. And then there are also many schools and programs actually offer these certifications to help people build their technical skills and development. And oftentimes, most schools will offer that do offer an environmental science program. They also offer some of these certifications. But to get the best return on your investment, or your ROI, you should find definitely an affordable environmental degree program, because this journey shouldn't keep you broke for like the next decade, especially thinking about the type of salary that you can expect to earn and with this type of degree. And after college, some scholars do go on to, again, these graduate schools to further their education, while others may choose to focus on more technical skills, such as, gaining skills in GIS, so a GIS certification, sort of map making, shown on the image on the left here. Or you could also become licensed to actually fly these unmanned aerial vehicles, to get a UAV or pilot license or drone license. And the cool thing about this is you can actually gain that license as early as being 16 years of age. So that's something that I definitely suggest you look at or look into, because having those additional skills will actually make you more marketable as well. And it can increase the type of pay that you have. So I'm showing here briefly just a STEM career Venn diagram of different degree paths that you'll have, career opportunities, and then share that more recently President Joe Biden actually shared that climate change is the #1 issue facing humanity. And he actually planned a $2 trillion policy to work towards a final goal of net zero emissions by 2050. And as a result, there's been a lot of money that has been put toward this effort. So that means this field of environmental science is continuing to grow. And there are a lot of different career paths, as shown here, that are going to be opening up and continue to open up for scholars who want to pursue this actual career field. And so I'm showing here again a number of different environmental science careers, and this is in no way inclusive of all of the different career paths that a person can follow to become an environmental scientist, or to have, if you have a degree in environmental science, different career paths you can follow. And so quickly here, sort of transitioning to like my own research in my own area. So I'm talking here about water quality. So I start with this riddle, and this riddle says that I am tasteless, I'm colorless, I'm odorless, I'm shapeless, but without me, there's no life. I am, and of course, the answer is water. Yay, water. So our planet Earth is often referred to as a blue planet because there's so much water that's on this planet, and people are often surprised to realize that how little of that water is actually available for us to actually use. So more than 70% of the Earth is covered in water, but there's actually only about 3% of that is fresh water, and less than 1% of that is actually available for human use and consumption. But we also know that about 60% of the human body is composed of water, and water serves these multiple purposes in the body. And depending on the climate where you might live, your body actually requires 6 to 8 cups of water every day. And our bodies get fluids from what we drink as well as the foods that we actually eat. And so, as an environmental health scientist and as a public health person, I often share that, again, most of the earth is covered by water. Most of our body is composed of water. So these are two facts that illustrate these critical linkages between water health and our ecosystems. And I'll share that, part of my own personal mantra is in life is to sort of be like water, to be resilient as water is, and then also to be open to change, to be fluid, to actually move. And so shown here, this is this inset picture here at the top left. This was actually a picture taken literally the first day that I was on campus at South Carolina State University. And then this is sort of my career pathway. I actually sort of went straight through. So upon graduating from high school, I began my collegiate career at South Carolina State University, and then I obtained both my master's and my PhD from the University of Georgia, and then completed postdoctoral studies at Emory University, where I was in the fellowship of research, the fellowship in research and science teaching as a postdoc, and then did some science teaching and training during that time at Clark Atlanta University and also at Atlanta Metropolitan State College, and then transitioned directly to Morehouse College, where I am now. And along the way, I did work at the same time or train at the same time with federal agencies, including USDA, South Carolina Department of Natural Resources, and also NOAA as well. So we can chat later about, what that looked like and some of those internship opportunities and stuff. But my research interest now lies, of course, within water research as well as microbiology and also science teaching, actually thinking about how we teach and how we actually learn. And I'll briefly touch on sort of some of the research that we're doing right now. We do have a federally funded project through the National Science Foundation. We're exploring this metagenomic approach to assess water quality and microbial load variability of an urban watershed. So the presence of microbial pollutants in urban watersheds actually warrants this comprehensive microbiological characterization of these water bodies in order for us to understand how microbial communities persist and change within an urban watershed. So where we're doing this is located in Proctor Creek watershed. So the watershed itself is about 16 square miles or 10,000 acres in size, and it's home to more than 38 neighborhoods, including some of the most economically disadvantaged and underserved areas in the city. So it's an urban and residential and commercial area or commercial land in this area, but it's also unique in that it's a watershed that is housed completely within a metropolitan city. And so we actually identified several sites. I'm not going to go through the sites, but we've identified several sites where we actually collect water from in this actual watershed. And then pictured here are just some images and diagrams of going through, like some of the scholars or undergrad researchers or bioscribes, as I refer to them, actually collecting water samples and also doing some of the processing of those water samples in the actual lab environment. This is a graphic actually showing what some of that data actually looks like from what we've been collecting in the watershed. And then this graphic I'll share here actually shows again what it actually looks like in the watershed. And then I'll briefly allow one of the scholars to share his thoughts on this.
I'm not really sure what that is right in front of me, but you can like see there's metal parts of stuff kind of like in that area, and still more trash, a lot of metal, plastic. So yeah, this is definitely like a no-go. People are dumping stuff in here like crazy.
Yeah, so this was part of our watershed assessment, our watershed observational study, where we went out and conducted an audit, just looking at, what the watershed actually looks like. The second part of the study, and what we're actually engaged in it right now, is phase 2 of the study, where we're actually engaged in sort of the metagenomic part of this, and actually looking at, DNA and stuff of our microbes and the microbiome. Of the water that we actually collected. So we've done like DNA extraction and quantification of the DNA, and then sending those samples off for sequencing to actually determine, like what's the function of those microbes that are in the environment, like the total microbial community and what's happening there. And so with that, we'll have some time hopefully later to chat about that. And so now we're moving to our scholarly activity, where Aaron will be leading this part of our discussion. And this is where you also can get engaged. And so to introduce the scholarly activity, so we have set up a Enviroscape or a watershed model that we're actually using, where we can actually explore the ways that human actions can actually impact the health and quality of our local waterways. So I'm going to stop sharing my screen so that Aaron can facilitate this next part of the discussion, and then we'll come back here. Hold on one second. Aaron does not realize he is muted. So Aaron, you need to unmute. Let me unmute for you.
All right, can everyone hear me? All right, so this is part 2 of the presentation. So what I'm going to do now is show you a demonstration of the ecosystem. This is a coastal ecosystem. So I'm just going to explain everything of what's going on. Over here, this was a green area, and now it's a construction zone. I still have a little piggy right here, but it's still a construction zone. Right here is a condo. Right here is a gas station. This is also a house. This is a farm area. This over here is a resort. This is a house. And this is a house as well. So naturally speaking, we all want clean water all the time, right? Okay, but what happens if our ecosystem gets polluted? Like this house right here has a septic tank. So what if the septic tank fills up and it's not getting clean, right? It's just gonna sit there, okay? Or what if over here at our farm, we have animals that go around free range and they poop. And I don't know if y'all can see my poop or not, so I'm just gonna move this house. And one animal just fell in the water. It happens. But yeah, what if they poop? That goes into our water, right? All right. So another good example. This is storm drains. So when it rains, storm drains are supposed to collect water, right? It's supposed to keep the water from going into the ocean, put more pollutants into the area. So if that overfills, this stuff goes into our water. And as far as the gas station, that I don't know, a lot of people know or not, gas station has like these underground reserves. where they house gas at. So what if this happens to leak? It's still in the ground, right? It's going to go directly into the earth. Let's see. Over here is a resort in a condo. This is a biohazard where all of that waste is, right? So they're supposed to keep these clean, right, and change them out. But what happens if this run into the water? See how it's polluting the water over here? And this is our ocean, guys. So also right here, you see boats that are floating in the ocean as well. They pollute as well. I know you all probably are familiar with the oil spill. Yeah, here's another set of animals right here that's in the green. This animal is dead because it has eaten something that was growing in this area where the polluted water is. So we always want to be mindful of what we do and how we do it, and we want to keep our area clean and free from pollution. So I also have another demonstration over here.
But before we move to that demonstration, if you'll note where Aaron had this spill, the spill was localized right here, but you can see where it's already starting to dissipate and it's starting to pollute these other parts of the actual ocean that's here. And then also, Aaron was going to demonstrate what happens if it rains on our area here. Like, what happens if it rains? Like, does the rain just go directly into the ground, or?
So yeah, do you all? So let's start with a soft rain. Misty, it's just misty. Where's the rain going? It's just standing still, right? But what if we have a heavy rain right here specifically? Look at all of that waste that's going everywhere, that's flowing out, and it was meant to keep in, right? So now all of that is into the streets, into the streets. Now it goes into our place where we had our storm water. Now it's polluted. Right here, these are actually mussels. This is our food source. So now our food source is polluted. So no longer are the animals going to potentially die. We as humans now risk ourselves getting infected with something. So we want to be very cautious of everything. And notice the roof. You see this roof right here has a slant. And the water is just, it's falling off. But what about this gas station roof? It's just stuck there. The water's stuck there. It's not going anywhere. Or what about this resort who has a flat roof, a flat surface? Stuck. So also this house, triangle, the water runs down. It has somewhere to go, but look where it's still going. Right into our storm drain. More pollutants. So in Atlanta, a lot of the buildings now, the newer condos, they have roofs that have grass on them. So the grass is meant to catch the water. And as a result of catching the water, it produces green light, which I think is a really cool thing. So we also have another one that's very similar to what city life looks like. And this is a little bit of city life and suburban life. So over here we have our city. Over here we have our agriculture areas, more suburban. But fun fact, a lot of people are moving out of the city into suburban areas. A lot of businesses are moving out into the city into suburban areas. So eventually they're going to become polluted as well. So let's see. This is a building right here. This is a school. So let me show you what the septic will look like for a school. A school has plumbing, right? But what if they're not doing the plumbing right? And if it's just dumping off into a creek? I'm from Birmingham, Alabama. So the school that I went to was in a black area. And the water went into this creek called Village Creek. And this creek smelled bad every day, especially in the summertime. So it happens even in buildings. If you don't have proper plumbing or proper way to discard waste, you still are damaging the community. And let's see something else. Do you all have a suggestion or something that you want to see happen? Because I'm pretty much like open. If you all want to see something, if you give me an idea.
Yeah, so for this part, for any of the scholars that are joining us, if you would like Aaron to place a pollutant on a specific location, or if you want him to demonstrate, like what the water may look like or rain may look like in an urban area, you can tell him where you would want him to actually spray the water. And, if you want him to spray a light mist or if you wanted him to spray a heavy mist or a heavy downpour, we're open to doing that for about let's say like the next minute and a half or next 90 seconds if someone wants to join in and let us know where they want him to sort of do a demonstration. If we were in person, we would actually allow the scholars like you all to actually do this part. So hopefully we'll have an opportunity later where we can do this in person and we'll have you all sort of engage and do this as well. So the question that's posted in the chat is, how does the tractor or farm area contribute to the pollutants in the water? So for the farm area specifically, and this was actually some of the things that I did for my actual research area. So where we have the tractor in the farming, they're actually going to be fertilizers that would be applied to the actual farm land itself. The fertilizers are applied there, of course, to help the crops grow. But of course, when it actually rains, as it does in other places, that's actually going to then serve as a vector for those fertilizers and potentially the pollutants that are in the fertilizer to then travel actually to the water, either lakes or streams, and that can then again pollute our the different water bodies. So Aaron, if you would like to sort of demonstrate by spraying on the actual farmland, we'll actually be able to see how those pollutants will actually sort of flow from the actual farmland there. So you can see now Aaron is spraying on the actual agriculture area, and you can see the water actually starting to pond there on top of that farm or agricultural land there. But then what also happens is you'll see as the additional rain actually starts to fall, the water will actually start to flow into that blue stream that's there. And if there were actually in some areas, especially in South Georgia, they apply poultry litter, so chicken poop to their farms as a fertilizer amendment, and that actually flows into the pond areas, and that actually has been shown to actually increase salmonellosis and campylobacteriosis in some parts of South Georgia as well. So a potential vector. As one of the scholars shared, they wanted you to actually do some heavy rain actually near the city and the farm area. So Aaron, if you can do some heavy rain near the city and the farm area, and maybe even where you have, oh yeah, look at it, like that's where there was that runoff that came from the city and from the school. So you can see that those pollutants it was just localized right there in that one area in front of the school. But now as the rain started to fall, you could see it start moving actually away from the city and those homes there in that farm area, and actually start to flow again into that blue area, into that stream. So again, hopefully this has been like a really good demonstration to show you all like what this looks like, so you'll think more about what happens here. And one additional thing was additionally when you have your pets, either your dogs or what have you, and you're walking your dog, you should also make sure that you pick up the pet waste as well, because that waste also can get into these various water bodies as well. All right. So I'm going to go ahead and share screen for like final couple of slides that we have here, and then we will end our conversation with folks today, and we'll have some time here for Q&A. So thank you, Aaron, again for facilitating our scholarly activity. So for our concluding thoughts here, we want you to know and share that again, a career in environmental science is a rewarding and meaningful method to positively affect people and the planet's health and well-being. Environmental health sciences is a wonderful choice for anyone who's interested in science. If you're interested in health and the environment, there's this range of various career routes and different pathways. It's definitely interdisciplinary. There is definitely a growing need for scholars to actually pursue this type of work, and it's a chance to make, again, this genuine impact into the planet. And it's also, it is, yes, a demanding field, but it's also a very rewarding career path that allows you to contribute to solving the world's environmental concerns. And with that, we'd like to acknowledge, of course, our funding sources for the National Science Foundation, Morehouse College Title III, our Morehouse colleagues and scholars, our Georgia Tech colleagues and scholars, as well as colleagues and scholars at the University of Georgia, the AUC Data Science Initiative. Yes, of course, the Science, Engineering, Mathematics Link Inc. Yay! Thank you for having us, SEM. And also our Vereen Research Institute, or VRI Bioscribes. And lastly, we want to thank, of course, our ancestors, our families, scholars, and students and scholars, all who take up the mantle for social and environmental justice. Sao Bono, I see you, you are important to me, and I value you. And of course, as pandemic restrictions have relaxed, we do want to take a point of personal privilege and share that we have resumed both our field and sampling and laboratory research and the VRI. So if you are a scholar who's interested in ecology, environmental studies, and organic research skills, even if you are a high school scholar, please definitely reach out to us because there are opportunities for you to both volunteer and to receive training in our lab group. And with that, we will entertain any questions, comments that you might have. You definitely can scan the QR code and it will link directly to the digital business card where you can have our contact information. Thank you again for having us and looking forward to answering potentially any questions or comments that folks may have. Yes, Ariane, and forgive me if I'm mispronouncing your name, but yes, when the rain falls and it strikes the city area, all of the waste is washed from there to the streams, polluting it, and also to those homes and stuff that are downstream from those areas. So even if you are a person who is who is living, like farther downstream from an area, if there is this rain that happens, then it might potentially be polluting your house and your home as well. Thank you all again for having us. It has been a wonderful time. And if you would like to contact us at any point after this, we'll type our contact information again in the chat, but you can also contact us directly at the Vereen Research Institute.
Thank you, Dr. Vereen, for your presentation. I will make sure to share that information with them through email so they can get your contact information as well as the Vereen Research Institute's information. And on behalf of SEM Link, thank you again for participating in this Teen Science Cafe event. We value your thoughts and feedback as we reflect on the event and improving future events. We ask that you share your feedback with us by clicking on the following link, as well as, yes, to answer your question, there will be a recording of this class available on SEM Link's YouTube channel. I can be sure to provide that in the follow-up email as well. Thank you again, Dr. Vereen. We appreciate it. And that concludes this event. Everyone have a great rest of your day and make sure to be on the lookout for future events.